I started recording.
Thank you.
Yeah. So, yeah. So we were here somewhere last time. Now,
Hello.
hello,
हो त्याने होल्ड केले.
hello. Shall I start?
Yes.
Yes, Vikram, please start.
Yeah. So when we think about design of tall buildings as a structural engineer, how does a structural engineer think about a tall building? Okay, and I'm not going to obviously take over what Guru is going to teach you, but this is just to help us understand as architects what is the role of the structural engineer and where do we come in picture. So I'm just going to talk about a little bit about how structural engineers see the design of tall buildings. There are 5 stages. One is the conceptual design. Second is the approximate analysis of what is the kind of stresses and all. Then there is a preliminary design and optimization. And finally, there is detailed calculation to carry out gravity as well as lateral loads. Yeah. So this is essentially what a structural engineer looks at. Now, what are the design criteria of the building? Again, broken into 4 components: strength, serviceability, stability. This is from a research paper which was published. I'll give you the details of that also. So it's not essentially our work, but this helps us in understanding how structural engineer, what is the information structural engineers require and what is the information that we should expect from them. Yeah. So number one is the strength. The strength is satisfied by the limit stresses. There are various methods of testing the strengths, but limit stress is the one which is more prevalent for high-rise designs. Serviceability is something where when we are considering a sway in a building, the top building is moving at the displacement is almost to the within the limit range of h by 500 to h by 1000. There is a there is a possibility that all your AC, all your lifts, shafts, and all, they will also have to tolerate those kind of deflections, right? So the serviceability, as long as it within this drift limits, the building is said to be serviceable, and and if it goes beyond, then obviously it is not satisfactory, or the building is not a very well serviceable building, right? Then the third factor is stability, which is both the buckling as well as what is the factor of safety which is considered for the high rises. It goes to 1.67 to 1.92 of the actual actual loads or actual stresses which are calculated. The factor of safety is considered way beyond. Then there is very important aspect of human comfort, I think, which we touched upon last time, which is about the acceleration of the building, particularly when we are talking about a sway in the building. Then what is the what is the sway? What is the human comfort which is associated with those sways, and whether those are within the limits? These are the parameters that a structural engineer will always look at, right? Of course, when Guru talks about it, he'll get into greater details of probably this, or he will talk about the other aspects of structures within the building. So the aim of the structural engineer is to arrive at a suitable structural system which satisfies these criteria, and to assess their structural weights in weight per unit area, in square feet or square meters, because ultimately from construction point of view, from architects perspective, we as architects or construction engineers, we understand fabrication and erection operations. So for that we need to understand what is the weight per unit area of the building. So from the initial conceptualization and all, we are quickly talking about the overall weight of the building, That weight is also going to be important for designing the foundations of the building, how deep it goes, what is the bearing capacity of the soil, how at what level does the foundation need to go to achieve a stable strata. All those calculations are after these initial design calculations, right? Then uh, the weight of the steel or the concrete is often a parameter for looking at whether the building is efficient in, because weight will also tell us about the cost of the building. It will also tell us about the weight and the logistics of how the execution will be done. So for a high rise, weight of the building becomes a very important criteria. The lighter the building, the higher you can go. The lighter the building, the more cost effective you are. The lighter the building, the faster you can have the construction of the building in place, right? Now, what does these weights include? The weights include floor systems, girders, braces, columns. All of these put together, they comprise of the overall weight of the building. Yeah, we are not talking about the live loads, we are talking about the dead loads over here. We assume that the live loads are within a much manageable limits, because these are not industrial structures. There are live loads only of the human load, which essentially is not, and the congregation spaces, if there are any, the live load becomes more relevant, right? So then once the weight is established, you also need to understand what the impact of the wind is, because of the wind there is a drift. As long as it is in the range of h by 500, that means if the building is 1000 meters, 100 meters tall, if there is a sway of about 200 then it is considered, or 8 inches, then it is considered to be yeah, then it is considered to be within the safe limits, which means that by the time your lift goes to the topmost floor, the lift shaft has deflected or swayed by about 8 inches. Okay, you can understand the problem, because normally you would say that the lift shaft, the tolerance levels are maximum, 25 or 30. Okay, over here, these are skyscrapers which you are talking about, sways themselves, not just construction fault, but the sway themselves to the tune of 200 Yeah. So, but that is a kind of tolerances, that is a kind of design that you got to work with. Yeah. Now the subsystems and components, there are floor systems, then there are vertical load resisting systems, there are lateral load vertical loads is gravity, lateral loads, the resisting systems is wind or any lateral kind of stresses, like in case of earthquake or something. Then connections are extremely important in high-rise buildings, because there is no way we can think of high-rise building as simple frame structures where beams and columns are acting in isolation and they are designed in isolation. Okay, uh, you have to look at the entire structural system as a whole, as a unit, and when you want to design these systems as a unit, you cannot separate out the column and beam structures. You have to look at the connections between these, even the connections between bracings and the junctions of columns and beams, very carefully. And lastly, particularly for high rises and all, how are the energies dissipated? Okay, for this, it is a there is a very important, very nice corollary. So, if you imagine the the oak and the grass, okay, the oak or the tree which are resistant, which resist the wind forces, they do not bend down. If the wind goes higher than their capacity, the oak gets uprooted completely. There is no mechanism that the oak or the larger tree has to dissipate the energy. Against that, grass, though weak and this, they bend and they allow the energy, the wind energy, to dissipate around them, and they are able to bounce back. to its original place. So thus damping the effect of the stresses, wind stresses. Yeah, right. So since 1990s, it has we no longer design as resistant structures. We don't no longer whether it is earthquake, whether it is blast or something. Instead of just making stronger and stronger buildings, we try to make buildings which are elastic, which are able to absorb the shocks and are able to restore the normalcy as fast as possible. So that is another concept which has come in a big way, and particularly after the World Trade Center disaster also, it has become these are lines of thinking which all the designers are closely exploring. Yeah, yeah. So that is regarding the yeah. So this is the site which I referred. This is the paper that I referred. So if somebody wants to go in greater detail about this, you can look at all the different kinds of floor systems. Okay, what are the different kinds of floor systems which are encouraged for both RCC and steel? This does not talk about timber structures. Steel floor systems, vertical framing system, lateral framing system, moment resisting frames. I think I missed out that slide. Looks like, yeah. So this one. So this slide talks about the what are the different kinds of. This is something which you will again be talking about in great deal in the structures class also. So in the last 40, 60 years, this there has been a transition from regular frame structures to modular tubes, bundle tubes, and so on. So there are various combinations of these systems which are used, which we'll study in greater detail probably in your theory of structures class. So you have moment resisting frames, you have shear wall frame systems, you have shear truss, outrigger base systems, you have frame tubes, you have tube in tube systems with interior columns, you have bundle tube systems, truss tubes with interior columns, and modular tubes, right? I won't get into this right away. Yeah. So these are, if somebody is interested in the structural bit of it a little more in detail, then that you can always go through this paper. They also talk about how the initial steps are, how the gravity loads are computed using all the live load reductions of the columns. Then column areas and moment of inertia are computed based on average axial stresses. Then the effects of winds are included in the determination of equivalent girder sizes, and so on. So, yeah, I'll copy this into the chat box. Yeah, so we'll take a small pause over here before we can look at some videos joined commonly. Any questions?
I think Vikram, let's proceed with the videos for now because I
Yeah.
don't think they have questions. Maybe after the videos, we can again open up for discussion.
Yeah.
न्यू फैंसी काउच हाँ कितने महीने की सैलरी उड़ाई इसमें?
Just a second. So let's switch off my video. We had seen the first video, right? We have to see the second video, or first video we are not completed. Hello? Should I start with part 2? Or should
Yeah.
part 1 was seen, or we repeat part 1 and part 2? Then should we repeat part 1?
Looks like Vikram. I don't think they are aware of that part one, or they can recollect.
Okay.
Guys, please respond because it becomes difficult otherwise.
Not so very long ago, though the city of New York was still young, from the land beside Central Park a new sort of building sprung. A montage of modern conveniences, the residential high-rise building grew. Running hot water, elevators, doormen, all of it was new. But it's been a long time that we've been placing ourselves in dwellings close to the sky and asking ourselves the perennial question, who gets the top floor and why? Were these vertical experiments reserved for elites, or to warehouse the poor away from the streets? Like all good stories, the high-rise has its own creation myth. The Bible's Tower of Babel and God's reaction forthwith. People of one language, high into the clouds the tower they built. But God disapproved, so people broken into many languages across the earth he spilt. The Romans were the first to build early apartment living, multi-story blocks called insulae, but made of mud and timber they were unforgiving. The higher the floor, the cheaper the rent. The working poor lived here, fires and collapses they couldn't prevent. In the cliffs of Arizona, mysterious forms of housing soon appear. It's been supposed these cliff dwellings are from where the elites commandeer. In rural China's Fujian province, in stacked circular homes of wood, whole clans of families up to 80 lived together for the common good. All rooms were equal, even windows, doors, and walls. For centuries, communal living was part of these people's laws. And another vertical wonder in Yemen's dusty sands, a medieval Manhattan of the desert, still occupied today, made of mud by the inhabitants' own hands. Vertical living got a major game changer when Louis XV commissioned an early elevator. To his apartment in Versailles from his mistress 1 floor above him, the king was known to hoist her down on a chair so she could love him. But without reliable brakes to assuage the common man's dread, they feared a contraption that went up and down could take off somebody's head. And as the elevator propelled the Industrial Revolution, people had to live near work and its industrial pollution. In Berlin, London, New York, and others, immigrants crammed in with no sunlight to be with their brothers. For decades, these dwellers lived, died there without much public sentiment. Cities were growing with this notorious new walkout called the tenement. By the end of the century, Manhattan's Lower East Side was the world's densest area by far and wide. Nobody cared until a photographer reviewed the situation. Jacob Riis's stunning collection would begin the conversation. In 1901, major housing reforms were read, but much, much bigger changes were ahead. The stuff of which cities are now made, whether luxurious or forlorn, the high-rise as we know it was now being born.
So just take a small pause over here. Want to discuss anything on this, particularly how what had given impetus, and parallelly what happened in means when she claims that Romans were the first to build multi-story structures. In Mesopotamia, you had the Katal Huyuk, which you entered from the top. So they were houses constructed in the ground. Of course, there was a ladder and verticality. Mohenjo-daro also, it had certain kind of construct, but how many of the cities, how many dwellings had multi-story kind of dwellings is something that can be deliberated. So that it's, to me, this is probably a Eurocentric kind of version of history of high rises, but we can compare it with with other histories also. Um, if you look at Chinese kind of typologies, you can compare it with the Chawl typology very much in India, and you can see that the number of stories, like the high rises, were becoming routine in not just in palaces and all, but even in industrial housing. So that is where the impetus for high rises was, and the elevator allowed those things. The urbanization, as we know today, largely owes a lot to these innovations. Densification of buildings rather than spreading it across over the land using the verticality of it. So, any questions on the first video, or anything you want to deliberate? Otherwise, we'll move on to the next.
No, nothing.
Okay. So the next is just a second. Yeah, you are able to see, right?
Yeah.
Looking back now, it's hard to believe there ever was a time when the standard high-rise was so universally beloved and in its prime. The century of the high-rise. The whole trend started with apartments like the luxurious Dakota building. It set an example for the middle class to also desire vertical living. By mid-century, the state-funded high-rise was an iconic emblem of the period. As one of the most commonly built forms of the century, numerous and myriad. A blunt instrument in the century-long struggle to find a place less obscure for those in the middle, somewhere between the rich and the poor. How did the publicly subsidized high-rise building go then, from solving the problems of the 20th century to being blamed for them? The invention of reinforced concrete was the first ingredient. Its early residential use on a Japanese island is expedient. Mitsubishi builds these tower blocks for workers mining coal under the sea. Concrete fends off typhoons, but living conditions here are not new. They're horrific to the nth degree. Meanwhile, the architect Le Corbusier envisions a more utopic use for concrete. He invents towers in the park, a design which would help the high-rise formula reach its peak. It takes a third invention to make the high-rise truly contagious: public housing, a new idea for this century. It's courageous. It happens first in socialist Red Vienna at a mass scale, while in the US the approach is more cautious under the Great Depression's veil. Mayor LaGuardia builds the first houses with New Deal money to progress, but proves that public housing is possible even in the chief capital of capitalist US. Master builder Robert Moses quickly gets to work. The war is over. The global population booms. And for the next 2 decades, the mass housing experiment blooms. Governments around the globe become committed to social equity, with efforts ranging from full public ownership to public-private affinity. The Soviets call it housing for the new man. The capitalists call it a middle-income housing plan. The New York City Housing Authority becomes home to 5% of the city's population. Britain's 4 million public sector dwellings add to this mass housing equation, rivaling the Soviet bloc, where Khrushchev's uniform prefab concrete slabs expand through multiplication. From Russia to Germany to Mongolia, 60 million people today still live in this high-rise cornucopia. Publicly sponsored housing isn't everywhere the diet. Beyond Europe, North America, and the Soviet Union, high-rise development is rampantly private, except for Singapore, Hong Kong, and isolated experiments, such as Tlatelolco in Mexico City, with ancient Aztec inheritance. The mass housing experiment is a decades-long story of idealism and destruction. Robert Moses's urban renewal obliterates neighborhoods and boosts the crime and segregation it claims to put in reduction. It leaves an often brutal legacy. Take the Bronx Air Rights building over yards of rail, or the bridge towers over a highway. The noise, the fumes, such an epic fail. At Ronan Point in the UK, a prefab building is so shoddily built, it comes down on itself, taking with it 5 lives. The high-rise honeymoon is ending. What survives? Alongside the vertical housing movement, a conflicting phenomenon, urban sprawl, has matured. The white middle class flees downtown on the highways planners such as Robert Moses secured. Now many high-rise neighborhoods, instead of housing this idealized middle class, have become warehouses for the racialized poor, neglected by the state en masse. The buildings fall apart from mismanagement, crime, corruption, and abandonment. Some communities fight back. Now, blaming the buildings for the social failures becomes the new credo. The demolitions begin here with the once admired St. Louis's Pruitt Eco. Down comes the concrete Berlin Wall, with it the Soviet Union and its mass housing construction sprawl. Yet in Singapore and Hong Kong, state-sponsored housing mounts. It's the Shangri-La of mass housing by some experts' accounts. On a global scale, it's a dawning of a new millennial age. Towers made of glass rise, and with them, another ideology takes center stage. Housing is no longer built as a tool for social equity and equilibrium. It's now a financial instrument of market capitalism. They call it the condominium.
Want to react to this? Quite a nice way in which it's done in a capsule. We want to pause over here, or we move on to the third?
We can move on.
Okay. But is it helping you, or what I want you to do is I want you to put the case example that you have taken in the historical perspective as well. So that's why we are talking about this historical evolution. So once you understand where it began, what was the original intents of high rises, what are the contemporary intents? For example, it started as a social housing experiment, and then we are talking about market capitalism. So what are those? And you really need to get a handle on these terms if you want to understand the entire gamut of high-rise articulation, right? Anyway, so we move on.
You don't need trend spotters to tell you, because it's not hard to see, that our world cities have mainly one way to grow, and that's vertically. For a century, high-rises were made of concrete and steel. Now urban jungles are made of glass, but what do they conceal? By the 1990s, the spirit of public housing had turned into a ghost, and the commodified glass condo rose as the new observation post. All over Asia, pop-up cities, megacities, and supercities increase in relevance, while next-gen slum clearance sweeps through the developing world's informal settlements. Urban slums, once seen as worthless, are now eyed with speculation. The rich return downtown and push the poor out into peripheral high-rises. A new form of deportation? In New York, even old concrete blocks are the target of speculators requiring only a bank's persuasion. A famous fight happened like this in the building where hip-hop was invented. The tenants fought off speculators' attempts to have gentrification augmented, forgetting all the signs as the middle class declines, that most of the new vertical urban future aligns. Only for the very rich or the very poor, the city ceases to be accessible to all for sure. The new luxury high-rise places are getting smarter, greener, taller, while the new low-rent trend downtown is to make the units smaller and smaller and smaller. Some critics say these micro-apartments of less than 300 square feet are another way of confining the young, the lonely, the cash-poor into prison cell-like retreat. Remember the tenements? This rampant privatized vertical development in the future, when it comes, such buildings made of glass, a material that hardly lasts, might well too turn into slums. Not all innovative vertical communities are designed from the top down. A vertical squat in Caracas has all the social features of a functioning small town. 80% of Singapore residents continue to live in public housing, proving that public concerns for citizens can still be arousing. And Hong Kong's standard harmony blocks, which always rise to the 40th floor or more, are now being considered in China, where surprisingly, public housing didn't really exist before. The legacy of mass housing, especially across Europe, holds some hope. Concrete blocks can be renovated, linked to the city, and become kind of dope. Scanning the centuries and the history of the high-rise, one sees social patterns emerge, disappear, and reprise. Vertical living can be modest, affordable, and humane in the right conditions. It just needs us to think about what our urban planet can be and to redefine our ambitions.
We go for the last one.
Yeah.
Dear Mr. Azizan, the 5-year boxing ban now stands closed. Please collect your
lie in the wood. Sun coming in, a little blind, dreaming of a lighthouse in the wood. Shining a little light, bring us back home. Where to find you in the backyard? Hiding behind our busy lives, dreaming of a lighthouse in the world to help us get back into the wild. Cause I know I've seen you fight. Won't you shine a little light? Confidence now.
So that completes the four-part series of the evolution of high rises. Uh, it is definitely a reality. It has emerged out of it has many social iterations. whether we call it social housing for some parts of the world, or we called it as imperialist capitalism. It is, whether in Dubai and all, it is all about the money or the economy of it. Whereas in our part of the world, we still are, look, many people in the country are still hopeful that high rises to a certain extent would solve the social housing problem the way it's solved in Europe for a long time. So South Asia, many of the projects are in the housing or social housing domain. Whereas elsewhere, so but increasingly we are realizing that just looking at singular housing perspective alone, they are bound to fail. It needs a mixed kind of imagination. It needs to be imagined as a complete neighborhood with all the other peripherals which are required for housing, not just housing units stacked one above the other. And that is where the future of high-rise structures, particularly in the land scarce regions, lay. Yeah. So with that, I open the floor for discussion, and we take it from over there. Kimaya, you want to comment on these films or something? Place your observations over here. Anyone who wants to react to these films? What did you feel? What did you think? What is your perspective? I'm sure you have had numerous deliberations regarding how high rise, whether they are good, they work, they don't work, whether we should go for high rise is not for our country, it is for whatever. So if we can deliberate all those, if we can put forth all those concerns and thrash them out over here itself before, there's no point in going forward if you are not, you have already not uh, kind of understood where we come from. So if you are not if you do not understand the relevance of it, there's no, it is difficult for you to, hello, it is difficult for you to really convince yourself about, making of it, constructability of it. Constructability comes later, but first you need to understand the context within which the building takes place, and what is the how is it working socially, okay, or within the economic setups, social setups, or whatever kind of how are people managing to be convinced to be staying in this building, what are their requirements, why do certain kind of high rises, why have they failed, what didn't work, what led to certain ghettos forming in certain parts of the world. So those are the questions that we need to look at when we are thinking about high rises. High rises cannot be think in isolated one single building kind of a concept. We need to look at it at the urban scale. That's what I said in the first lecture itself. So this is what I meant. Yeah. Any reactions from your side? Would like to hear from you. What did you gain out of these films? What did you observe?
I found the point where when they said that high rises have become like a tool for capitalism now more than a housing strategy. Like
That is in Europe and America. In Singapore and Hong Kong, it still works as a social housing
hmm,
tool. Even in China.
yeah, so maybe the context plays a like a larger role in this.
Anyone else? Madhura, Lalit?
I have actually I have never liked the idea of high rises in the past few years, but I don't know, maybe because now we're actually studying them, and I never researched about what is the social context and what is the reason for it being a high rise building. But I don't know, I think it's given me a little bit of interest now to actually see if there's a larger reason why in some context it may fit, because I thought it might be like a stacking of a similar kind of system, and what is it doing architecturally then. Okay.
So, if I may ask, you remember in the first video, first film, the Romans, the cost of the rental was lower. The poor people were placed on the upper floors, and the richer ones occupied the lower floors. Okay. As against that, today the richer people are occupying. So if you look at the premium of high rises, richer people occupy the upper floors, and the poor people are on the lower floors. So that itself gives you a clue as to what 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 has been the shift in the desires of having an occupancy, right? So the Romans, obviously, it is very clear. No? There was no lift or anything. So only a poor man can be made to struggle to go all the way till the top. Okay, where the safety, the falling means all the risks which are associated with roof fires and all that, they are first taken. Even the escape route is the longest for the poor man. So the vulnerability is also more. But as with steel and concrete, these issues of verticality, transit, lifts, and all these are taken up, automatically those dynamics change. Then they are no longer about just stacking up built space and livable space. It becomes more about, as he calls it, as observation posts. Okay. So when I am in the, if a rich man is in the apartment, it is about the vista. It is about being able to see the entire city. Okay. So today, the way, even if you look at all the advertisements of high rises and all that, and even when you talk to any of your parents or relatives and all, if they look at, or somebody who's already staying in a high rises and all, you will realize that it is actually the sense, a certain notion of having arrived, having a kind of open view. Okay, which otherwise in low-rise structures with buildings coming so close to each other, we have completely lost that open view idea, right? Apart from that, also, in my first presentation, I showed a monastery which was in the mountains. Okay, so this desire of mankind to reach at a higher spot and be able to see around is not new. It has existed, even prehistorically. So now imagine we have we as with technologies and all, we have the ability to put ourselves, make a mountain, or create a mountain where none existed before. Mountains which can be occupied. Okay, mountains which not only catch the rains and all which traditionally they were supposed to catch, but mountains which can be occupied by different people, different activities, different functions. Okay, so at least to me, yes, when you look at the cost and when you look at the certain kind of context and all, the way they are executed in India, there is, it's extremely pathetic, and we don't want to see high rises and all the way they are. But I don't see that as as the reason why we should shun them completely. I think what our role is to be able to see what are the potentials within the high rises, get to the essence of why people would go for high rises, which people can afford high rises, why, how do we make them affordable, even with the vertical, because whether I move from the city center to say 100 kilometers away and have a metro rail established, or I put a vertical and I go vertically and have a the amount of energy I'm consuming is almost the same, right? So what is even that argument, which was earlier given by Charles Fourier and all, it's better to go for low cost housing and go the urban spread, is that argument from the cost of transport alone, that argument no longer holds good, because you have transportation vertically as well as horizontally. The argument where we fail is the infrastructure argument. And the argument where we fail is the development plan, the strategy, or means a clear strategy of what kind of high rises do we want. How do we make them work? How do we make them not put burden onto the civic infrastructure? That is where we need to really be careful about, and also the kind of skyline that is emerging out of it. So, for example, there are certain skylines which you immediately you gather, and they have become icons. But if you look at, just come out of Mahalakshmi station and look around the kind of mill lines, the development of mill lines, you don't want those kind of, you can't associate with any decent kind of urban space. That is where we need to step back and look at where have we gone wrong. High rise per se, there's no point in saying high rise per se is bad or it's wrong. There's no point in saying that. There are some conditions where you will find that high rise are the solutions. Okay. Yeah. Mehak, you want to ask something? Yeah.
Yeah, I just had this question, maybe an observation also. When we are looking at low-rise structures, the typology across the world or in India vary so much. But in case of high-rise, there is no much variation seen, or probably there is. They all look similar. They could be in any part of the world, but they all look very similar to each other.
That is because of the monopoly. So if there is very little, and there is a standardization which becomes more, the safety factors and standardization becomes much more important. But I don't think that is correct. If you look at some of the high rises which are coming up today, there is a variation. Except for the verticality of it, there is a lot of variation in the way it is imagined, in the way it is manifested, the way the treatment is. Um, are you referring to all the glass high-rises structures? Yes, that is one typology. But if you look at the treat and you look at the green kind of verticalities, then there is variation over there. Timber high-rises, there is variation over there.
Hmm, perhaps, or maybe I was just referring to apartment high rises.
That is
How?
because of a certain standardization. Because you see, when you invest so much of money, automatically there is very little experiment, because people want to do which is proven. Okay. So how do you take risks on designs? How do you take the risks on designs which have not been proven? So that, and then how many people are there who would give you those kind of designs, who would put that kind of energy in developing new contexts? How many contractors are there? How many manufacturers are there who would give you different kinds of components? So construction of a or manifestation of building is a function of not just your design ideas, right? It is about logistically what is possible. How do you put it together? So the what is the contractor comfortable doing? And I wouldn't entrust a contractor who has done only a 5-story building to build a 70-story building. Okay. So in India, it's like, though the pre-stressed concrete is, if you speak with the Satish Jain, you'll realize that though he has been working with pre-stressed concrete for so many years, it is slowly catching up, but he still has a monopoly of it. Not all the contractors are working with pre-stressed concrete. So even in steel in high rises, the fear associated with steel failing during fires is so strong, and our fire regulations and all are so poor that we still don't we are not very bold about accepting other newer materials. Concrete still seems to be one of the best options for high rises in India. Yeah.
Yeah, I think I got my answer.
Madhura, you're still having your hand raised.
Yeah, yeah. No, I just had a question. When you mentioned you wouldn't trust a contractor who's built a five-story building to build a 50-story building. In terms of like, is there a lot of difference in the amount of challenges that you face when it comes to a building which is probably a 7 to 10 story building and then a high rise? Obviously there are, but I don't know to what scale are the changes, because then we look at buildings but maybe they're not high rise, you know. Very very silly doubt actually.
See, let's look at it this way. Uh, let's start with the capacity a contractor has. Okay, in executing a project. Okay. Now the capacities are both economic, monetary. What is his financial capacity, as well as his manpower. What is his manpower capable of? Okay. So in terms of his manpower, he would have certain engineers, he would have certain supervisors, he'll have some laborers. Okay. And in terms of his the material and the tools and equipment that he has, he will have certain mixers, he will have certain scaffolds, he'll have certain that kind of investment, and he will have a certain financial kind of balance in the bank. So if there are any risks, then he is able to handle it. Now, if a person has been doing 7-story building for you know 30-40 years, okay, without a major shift in his knowledge system, without a major shift in his manpowers, without a major shift in his engineers, the kind of engineers he is employing, without a shift in his tools, okay, without additional finances is something which he can manage probably. He might have done 50 projects and he would have had the financial background. But the knowledge system that he is coming with, or the manpower that he is coming with, whether they are in a position to handle a project of this scale and this complexity. Okay. For example, a 7-story building would have a certain kind of lift. We won't talk about lift banks, right? We'll talk about certain lift. The speed of the lift that he is used to is, say, maximum 1.5 meters. Okay. So the tolerance also are crude. Suddenly you are asking to make a 60-70 story building where the speed of the lift has to be 4 meter per second. Okay. And the tolerances are coming down to 10 millimeters and so on. Okay. Will you trust his manpower, his people to deliver that system without him having actually proven that he is capable of doing that? Okay, so high rises is not just about increasing the number of stories. It is not just about the verticality. It is about, as we say, as I showed you, even the structural engineers, he's looking at those 5 parameters. Okay, one is stability, one is serviceability. That serviceability component of it becomes very important. Then he might have the scaffolding system, he might have people trained to 7-story building. Imagine the scaffolding being put on the 70th story and they wanting to put up a person to fix glazing from the outside. Okay, there's a huge difference. Okay, so and even the technologies change. So high rises no longer employ scaffolds completely from bottom to the top. Okay, the way in which the scaffolds, the way it is in tiers. So even the at every stage, the whole stage gets lifted up, and you create some kind of. Then you have deployment of giant cranes to put those units in place. So there are so many other kind of infrastructure which are simply not possible with a small time contract.
Yeah,
I mean, it's as good as saying that. I mean, can I trust seven-story a regular contractor with a metro station? It's a completely different engineering feat. You need to have that kind of knowledge and base to execute. Yeah. So these were the two introductory lectures on high rises. Okay. Next time we'll start with the foundations, deep foundations, while this discussion for studio will continue, we'll try to cover the lectures as fast as possible. We won't dwell on it too much unless you come back and ask specific questions about it. So while your case study, when you're presenting a case study, we'll be learning through your studio itself quite a lot on this topic. Otherwise, the introductory sessions of the high rises are more or less done. Yes, in terms of services, in terms of movement, all those 5 parameters that we talked about, we will continue talking about it, but with reference to your case examples. Yeah. Is that okay?
Yeah, works.
Okay. See, we have time till 3:15 officially. Okay. So, in this class, because lecture cannot go on till 3 hours, it becomes too much. And so we need to utilize this last hour in a certain way. How do you propose that we should utilize this time? If you, because I told you last time, if you bring some readings, some material which you have already gone through, we can have a discussion around it. Because on Tuesday's class, you won't know what one group is doing and the other. So can we utilize this to exchange certain case examples across the class?
Yeah.
Yeah. Does that work for others?
Yeah, we can take some building and analyze it. Like maybe you
Yeah.
can show us how to get started.
Yeah. So we can start doing that. Or do you want to do it today itself, or you want to take it up next class? Because now, though, I think you will need time to just do your own studies. So until and unless you get that in order, there's no point in commenting on it, right?
Yeah. We can start that next class.
Yeah. Okay. Okay. Good. Okay.
Vikram,
हाँ बोल.
we don't have any example in bioclimatic architecture of a skyscraper like Kenyang's or something. Do we have? I don't think we have. So we can take that up next class or something like that
Okay.
to start
चलेगा.
with.
चलेगा.
So then we can focus on the environmental systems within the high rise. Something
Yeah.
like
Yeah.
that.
Absolutely.
Okay.
ठीक है. चल. Let's call it a day.
Yes.
Okay. Bye.
Thank you.
Thank you.
Thank you.
Thank
Thank
you.
you.
Thank you.